All right, in this video, we're going to talk about systems of equations, specifically the elimination method. And this method can prove very useful sometimes when substitution would be a little tricky or difficult. Okay, let me show you what I'm talking about. In a previous video, we talked about how to isolate one of the variables. So for instance, in this case, if I try to add 2s to both sides, right? You do that, you should end up getting 10r equals negative 2 plus 2s, and then when I divide by 10, you can see how we're going to start getting a lot of fractions over on this side, and that's something that's going to make our arithmetic a little messy, so we want to try to avoid that if we can. And here we're going to use the elimination method to make that process a little easier. Okay, so the idea is to get one of the variables to more or less zero out with the other equation, so that in my new equation I will get just a single variable that I can solve for that one. So let me show you what I'm talking about. If I look at the s's, and really it doesn't matter, you could try to eliminate the r's if you wanted to. Either would be fine, but I'm going to choose the s's in this case because they're smaller numbers and it's going to be a little easier to work with. All right, so if I multiply this top equation by 2, I'm going to multiply the whole thing by 2. So what I end up getting is negative 16r plus 6s equals 20. And when I do that, when I multiply both sides, the entire thing by 2, I get a different equation, but they're still equal, right? So all I did was change the way it looks. I didn't change what the value of r and s would be. And then if I notice right here, right, that's a 6s. So if I can get this to be a negative 6x, I know 6s plus negative 6x is 0. So on the bottom one, I'm going to multiply that one by 3. So what I get now is 30r minus 6s equals negative 6. All right, so now the 6s and the minus 6s eliminate, right? They're gone. They turn into a 0. And on the left side, I have minus 16r plus 30r, which will come out to be 14r. 20 minus 6 is also 14, divide by 14. And I get r is equal to 1. From here, I'm going to do the exact same process from substitution. I'm going to take this newfound r value of 1, and I'm going to plug it into this right here. And I'm going to solve that to find out what s is. So here we go. I have 10 times 1 minus 2s equals negative 2. This becomes 10 minus 2s equals negative 2 minus 10 minus 10. That's a 0. I get negative 2s equals negative 12. Divide by negative 2. That's a 1, and I have s is equal to 6. So my coordinates for that could be 1 and 6, and I know that it's r and s. All right, so now what I want you to do is try this same method down here, use the elimination method. Pause the video, try it on your own, and then we'll come back and check it together. All right, now that you had a chance to try that on your own, let's come back and try to get these things to eliminate, right? Again, you can choose either to eliminate the x's or the y's. It doesn't matter which one you eliminate, you'll eventually get to the same coordinate no matter how you do it. I'm going to choose to try to eliminate the x's because what I've noticed is if I multiply this by negative 2, I end up getting negative 6, and negative 6 plus 6 would be 0. And by doing this, I only have to change one of the equations, right? So I get negative 2 here, and what that ends up giving me is negative 6x plus 4y equals negative 14. And then my other equation was 6x plus 5y equals 9. So now what will happen is I have minus 6x plus 6x is 0. 4y plus 5y is 9y. Negative 14 plus 9 is negative 5. Divide by 9 to both sides. That ends up being a 1. And I got y equals negative 5/9. All right. So now what I'm going to do is take this and plug that back into, I'm going to choose the first equation because the numbers are a little smaller, so it might make it a little bit easier for me. So now what I end up getting is 3x minus 2 times negative 5 over 9 equals 7. Okay, so then I got 3x, and that ends up being, distribute that to that, I get plus 10 over 9 equals 7. So I subtract 10 over 9 minus 10 over 9. And what you can do now is I'm going to change that 7. Okay, I'm going to erase that. So I still need it to be 7, but I need the denominator on the bottom to be 9 so that I can do my fraction subtraction. And then 7 times 9 would be 63. Okay, so then I get 0 over here. Now I've got 3x equals, and that would be 53 over 9. And then if I multiply by 1/3, which multiply by a third, that ends up being a 1. So you get x equals, and now I have 53 times 1 is 53, and then 9 times 3 is 27. So now I end up getting a fraction for my solution, which is okay, just not a lot of fun. I have 53 over 27 for my x value, and I have -5/9 for my y value. Okay, so sometimes you can get fractions. We just got to get good at dealing with them by practicing using those fractions. Okay, so now then, if we come back up to the top and let's talk about it real quick and recap it. So elimination, the goal is to get one of the variables, it doesn't matter which one, to eliminate when I add them together. You may have to multiply one or both of the systems by a given number so that you can achieve that goal of elimination, which leaves you with one variable. Solve for that variable and then replug that variable back into the original so that you can find your last missing variable. So sometimes elimination is easier, like in this case, when all of my variables have a constant with them, might make it a little difficult to do substitution, that you'd have to deal with fractions a lot earlier than you would sometimes have to. So just pay close attention to substitution elimination. Sometimes one of those two methods will lend itself to be easier than the other, but either one of them works in any given system. If you like one over the other, feel more than free to do it that way, but I just want to show you both so that you've got options when it comes to solving systems of equations. Hope this video helps, and we'll see you in the next one.